alternator MAHLE, 14 volts, 120 amperes, made in Slovenia. This alternator can be used in different agraric equipment and especially in Europe-made tractors. And I will show my way to test such component. I will disassemble alternator to show major parts and to perform testing separately. Voltage regulator adjusts magnetic field intensity in rotor windings. Stronger magnetic field in rotor gives higher output of voltage from alternator. Difficult to test voltage regulator directly, but it can be easy tested indirectly, and I will show this in a minute. Little bit theory about how alternator works. Initiation current reach rotor winding and creates magnetic field. That magnetic field crossing stator windings, and that magnetic field vibrates electrons in copper wire. In this way created alternating electric current in the stator winding. When the alternating electric current reaches diode bridge on the rectifier, it will be transformed to direct current. Visual inspection of the component is very important. Insulation spacers, those very important and must be put back to the place. We have rotor with axle and two copper slip rings and with rotor copper winding. Stator with copper windings. Rectifier with diodes inside. Actually, it is possible to see diodes beneath that plastic cover somewhere in this area. And major function that rectifier performs is to convert AC voltage to DC voltage. In the stator, I'm testing windings with multimeter, and usually you have 3 windings in the stator, which is connected in one spot here, and that spot I'm calling the ground. And as you can see here, they all 3 separate windings connected in that major spot. And I'm performing a resistance test and comparing resistance in between all those 3 ends. And point is that we should have almost similar readings in between those 4 spots. Next step, to check resistance in between windings and battery port. With this step, we testing diodes in the rectifier. Now reversing the probes. And one more time. Next step, indicator light port to stator windings. We must remember that indicator light provides initiation current to this alternator. Here we must see almost equal readings, and when we changing polarity, we must see open load in all four spots. Rotor test is very simple. Measuring resistance in between both slip rings, and resistance must be around 3 ohms. And resistance in between slip rings to shaft or to casing. Here we must have open load. Sometimes testing of internal components can give you faulty conclusions because of testing conditions and working conditions can be different, and such things as vibration, temperature, or even humidity can give different results. Therefore, it is very important to do initial test on the vehicle. With this step, I will simulate initiation voltage with those crocodile clips and with a simple 9-volt battery, which I will connect to indicator light port here. At the same time, I will connect multimeter positive probe to the battery port on alternator and multimeter negative probe to the casing. And the multimeter screen you can see here. Using usual battery drill to give little bit spin to our alternator. As you can see, it produces voltage. It looks like voltage little bit in the high side, but when I will connect test light, which is the same as the load, performs function of the load, voltage will be normalized. Test light connected, and as you can see we have 14.4 volts. Now I will disconnect capacitors and measure voltage again to compare differences. Even with disconnected capacitors, alternator able to produce voltages, but little bit lower. Capacitor still disconnected, but in this time I'm applying the load with test light. And again, both capacitors connected. Applying load with test light. And you can see I have normal voltage. Initial testing can be performed when alternator is still on the machine, but in this case you must disconnect all those capacitors. Take resistance measurements in between battery port and casing. When flip probes and measure again. As you can see, must be open. In other way, we have readings. I'm starting with simple steps. Initiation voltage and fuse. Brushes on voltage regulator. They sometimes tend to be stuck. Now I want to show how I'm testing indirectly voltage regulator. I have 9-volt battery, the same battery, with alligator clips and extension lead connected to the probes. And I also have multimeter connected to battery port and to the casing. I will try touch with those probes slip rings, provide initiation current, just slightly and very careful. And at the same time I will rotate rotor with battery drill. As you can see here, alternator provides voltage little bit lower that it must be, but it's just because I have bad contact in between those probes and slip rings. That means that internal alternator components working properly, and if you have issues, they must be related to voltage regulator. And that's all I wanted to show. Good luck!